statistics, data mining, and machine learning, we fit models. That means we find some historical data and we look for a set of mathematical formulas that will allow us to reproduce that data. Of course, in the real world, we'll never be able to perfectly replicate the historical data, but we would like to come as close as possible. We have metrics such as R² and RMSE that measures how close we get. In every course you take, you've been told that you need to validate your models. Usually, validation data is a random subsample of your historical data set. If you have a time series, in order to preserve the sequencing of the data, we'll split the timeline into two parts. The first part to use for training data, and the second part for validation. In finance, this procedure is known as backtesting. In the textbooks, they will tell you that the reason why you need to validate your model is to prevent overfitting. Overfitting is a deep statistical concept that many have found it difficult to grasp. I'm not going to get into the academics of overfitting here in this video, but I want to show you an example of an analysis that I recently did with coronavirus data. And in the process, I demonstrated the value of validating my models. I was getting frustrated with opening my Twitter account every day and seeing all these alarming stories that were reporting the number of cases and deaths from Covid19, saying that they increased yet again. This last week, it was all about Italy. The big deal was that the number of new deaths in Italy broke a record, reaching the highest level since the outbreak first started in the northwest Italian region of Lombardia. Because of these reports, people were concluding that the situation in Italy was spiraling out of control. I have a feeling that this story might not be so simple because fatalities hitting a new high was a foregone conclusion. We know that there was a surge in new infections in Italy a week ago, so there will be a predictable surge in new deaths a week later. The real question here is not whether more people are dying from COVID-19. The real question is whether the containment measures taken by the Italian government is working or not. So like any data scientist, I went ahead and pulled down the data. I focused on Lombardia because it is the first region where the outbreak started, and it's also the first region to impose lockdowns. In the flurry of data analysis that flooded the media, the growth rate of infections have often been described as exponential. So one way to understand exponential growth rates is that every X days, the number of cases will jump by tenfold. Contrast this with a linear growth rate, in which the number of cases will go up by 10 cases every X days. Obviously, 10 times is a much more serious matter than 10 cases. So with the data, I can build models of the growth curve. I considered three main candidates: exponential, quadratic, and cubic. Quadratic and cubic belongs to a class known as polynomials. Remember that there's a huge space between the linear and the exponential, and polynomials sit in between in that big space. As you can see from this chart, much to my surprise, the best model for the growth curve in Lombardia was not the exponential. It is the cubic, the purple line on the chart. The exponential model eventually overestimates the number of cases, As you can see that the orange line here pulls away from the black dots, which indicates the actual case count. The reality is less scary than what the exponential model dictates. Recently, US President Donald Trump said that he wished people would not have lied to him 2 weeks ago. Actually, 2 weeks ago, we didn't have the data from the last 2 weeks that we have today. In times of great uncertainty, be cautious about hindsight bias. Think back to the Italians. When they decided to lock down the region of Lombardia on March 8th, they didn't have the entire growth curve that we are seeing today. They only have the portion up to March 8th. So perhaps the media was correct, I thought. Perhaps on March 8th, when they looked at the curve, the exponential model was appropriate. The way to find out is to go back to the data. Here's the chart that shows the data from February 25th up to March 8th, omitting the last 11 days. You'll notice that even at that moment, the quadratic or cubic curves were better fit for the historical data. The growth curve was never exponential. I now have two sets of models for the growth of cases in Lombardia. One set of models was based on the pre-lockdown data, while the other set is based on the entire data set up to March 19th. In both cases, the cubic and quadratic growth curves were better fits than the exponential. For the pre-lockdown model using data up to March 8th, the cubic and the quadratic were very close to each other, and it's hard to know which one is better. This is where backtesting comes in. We can use the pre-lockdown data to forecast the case counts for the days between March 9th and March 19th. Because we have official statistics for that period, we can check how good our models are in predicting the future. This next chart shows the startling result. Here on the left side of the chart, prior to March 9th, the curves are actually fitted to the historical data. On the right side of March 9th, the lines represent projections based on the models fitted to the earlier data, and the black dots are the actual case counts that we can compare the lines to. First, you notice how wacky the exponential model is. The further out you go, the greater the overestimate of the number of cases. Look at the quadratic model, that's the yellow line. This was working very well until March 8th. And then after March 9th, as time passes, the quadratic model systematically underestimates the number of cases. The cubic model, however, does not show this problem. That's why the cubic model is actually the best model here. I've just performed a model validation exercise. The data from the pre-lockdown period was used to train the models, and the data from the post-lockdown period was used to validate the model. The quadratic and the cubic models both performed very well in fitting the pre-lockdown data. However, the cubic model distinguished itself by generating predictions that were closest to the validation data. Model validation is necessary because some models fit the past well, but cannot predict the future. If you like this video, please share with your friends and suggest future topics below.
Principal Analytics Prep. Prepping you for the data revolution.